I mean, Wagner proved that they moved, but no one knew why. And there was a theory that came about from a lot of research called plate tectonics that described why the continents moved. It explained continental drift. And that was very important. And once they figured out plate tectonics, then everyone accepted continental drift. So plate tectonics says that the crust of the Earth, which includes the ocean bottoms and the continents, are all on plates. And those plates are moving, floating on the mantle below. The mantle made of semi-molten material, rock. We see here a picture of the oceans. Well, this is marine biology. We're really more interested in the oceans than the land. Picture of the oceans, including all the depths at the various places. The darker blue means deeper, and the lighter color means more shallow. So you can see in the middle of the Atlantic Ocean, there's a long, shallow area right there. Those are mountains that are in the middle of the ocean that have come up where the plates are separated. The plates are separating, liquid hot magma comes up out of the earth and forms these mountains right there in the middle of the ocean. And there's a lot of volcanoes right there, a lot of volcanic activity running along the whole thing. And look at there, right there, y'all know what that is? 10 points! If you can tell me what that is, it's an island that's right on this mountain range, and the reason why it's an island is where this mountain range sticks up so high that it goes above the ocean and forms an island. 10 points if you can tell me. What we call that? I'm going to the front here.
No, stop. Okay. Sure. Yo, Greenland?
That would be a good
is that
name.
big island right there. Oh, swear, alright, bet. We're straight.
Incorrect. Just see if you know it. White correct.
It's Iceland.
Orange correct. Purple correct. Anyone else?
Did Payne get it correct?
Hold on.
Wait, did we get it wrong?
Blue correct.
He didn't say pink correct. Yes, he did.
Yeah, this is the first one.
I thought he said he got it wrong.
Green correct.
Did Pink get it correct?
Pink correct.
Alright, bet.
Tighten up. You tighten up.
Iceland.
Great, chill out.
That's called Iceland. Iceland is just where the mountains that are under the ocean have come up so high that they're above the ocean. That's what Iceland is. Isn't that cool?
Very.
There's all kinds of volcanoes in Iceland. As a matter of fact, Iceland gets most of their power from geothermal heat.
Holy moly.
Holy moly.
Sounds scientific.
That's science.
Now, some of the proof of plate tectonics lies in, you need to understand these magnetic sounding readings. Pay attention up here, Tone.
I'm recording you right now, man.
Well,
We gotta get a better angle.
we don't want to record like that.
I had a great angle.
We gotta get a better angle of you and the screen.
Here we go. So, the bottom of the ocean floor. Now, here's where we are. Let me get you straight here. So, right here in the middle, everybody looking right there in the middle, right there is this line right here in the middle. And what they did during World War II is they would drag big magnetic equipment down through the oceans, trying to look for enemy mines and submarines and things like that. And they noticed that they could detect the magnetism of the rock. And the rocks they found, have magnetism associated with them. Wherever you see dark lines, that means the magnetism has a certain polarity. And wherever you see white, that's where it has a reversed polarity. So let me explain what this means. When lava comes up out of the mantle and comes up and hardens into rock, it contains little tiny pieces of metal in it. And those little pieces of metal, since it's molten, will all turn to face north, just like a compass needle does. Are y'all with me? You can't really understand this without paying attention here. So we got this liquid hot magma coming out of the earth, and it's liquid, so all the little pieces of metal, because of the magnetic poles of the earth, they all turn to the north. And then the rock hardens, and the little magnetic pieces are stuck in place, and they're all pointing north. And that represents these dark layers here. But what scientists figured out was in the light parts, they're all facing south. In the dark part, they're facing north. In the light part, they're facing south. In the dark part, they're facing north. In the light part, they're facing south. You know what they've discovered here? The magnetic reversal of the poles. Did y'all know that this happens? About every 1,000,000 years, the magnetic poles reverse. And north becomes south, and south becomes north as far as a compass needle is concerned.
So is there no point of wait, then what?
It'll reverse. Like right now,
No,
your
I'm saying
compass
so a
points
compass.
north.
So a compass will be messed up.
A compass would point south in a magnetic pole reversal.
How quick does that happen?
It happens over a period of about 100 years, they think. We've never had one happen during modern human civilization, so they don't know for sure. But they think it happens over maybe 100 years, maybe 50 or 100 years.
So it could happen soon?
It could happen. Yeah, it could happen soon, or it hasn't happened for 400,000 or 500,000 years, and I think it happens about every 1,000,000 years. But here's the thing about it, is it's very inconsistent. Sometimes it'll happen in 100,000 years, sometimes it'll take 1.5 million years. So it's inconsistent. And it has to do with the outer core of the Earth. Do you remember Earth has a solid core in the center? The inner core of the Earth is solid, but the outer core is liquid. And as you have the Earth turning, that liquid is sloshing around. That liquid metal is moving. And that's what creates Earth's magnetic field. Earth has a magnetic field around it, and that's the thing that moves compasses. Have y'all heard of the Earth's magnetic field before? And it has to do with the fact that the Earth spins. If the Earth didn't spin, we wouldn't have a magnetic field. So it's the Earth spinning and all this moving liquid metal in the outer core of the Earth makes our magnetic field. And for some reason, and scientists don't really understand why, the mass of liquid metal that's in the Earth kind of changes, maybe gets turned over or something, and that changes that reverses the magnetism on the Earth. And that seems to happen every 500,000 or 1,000,000 years or so. Does it say in the reading how often it happens?
What does that change besides just a compass?
It changes a compass.
450,000.
Every 450,000 years. Okay, so it's about 500,000 years it normally changes. But it's very erratic. Sometimes it changes in 100,000 years, sometimes it changes in 1,000,000 years. But it would affect organisms. It would affect, because we know that birds use an internal compass to migrate. Whales use compasses to do their migrations. And also, the magnetic field helps deflect cosmic rays that are coming into the Earth and keep them from hitting the surface. So during the point of reversal, we might let in more cosmic rays. And so scientists are still trying to understand all the implications of magnetic reversals. It may partially cause some extinctions on the planet, they think, that whenever there's a magnetic reversal, there might be greater number of extinctions of organisms who get screwed up because of it.
But we never know what's going to happen.
We don't know when it's going to happen now. So it's unlikely that it will happen tomorrow because it only happens every 450,000 years. But it could. It could start tomorrow. It probably wouldn't be like that. It would be over a gradual period, maybe 50, 100 years, 10 years. So they don't really know exactly how long it takes. Does it say in the reading how long it takes? Well, I don't remember. I wrote this a while ago. So check it out.
Yeah.
So, if the magnetic reversal of the poles happens every once in a while, then what happens here is new lava comes up. It's all pointed one direction, and then there's a magnetic reversal of the poles, and the lava that comes up, it points in the other direction. And some moves this way because this plate is moving that way, and some moves that way because this plate is moving that way, and you end up with magnetic stripes on the ocean floor. The fact that these magnetic stripes exist supports plate tectonics. You wouldn't have stripes if the plates weren't moving. That's evidence for continental drift.
And those stripes are made every like 450,000 years.
That's right. They can tell how often the poles flip by how wide the stripe is.
Yeah.
Right? If it was a wider stripe, that means it took longer to flip. You can't see the stripes. You can only pick them up with the magnetic detection devices that the Navy was using to try and find mines and submarines.
Are they confused?
What's that? They were. They didn't know what it was, and scientists figured it out. Isn't that great? Y'all, this stuff is incredible. Furthermore, what scientists then did, now that they understood that the plates were separating, they aged the rock of the ocean floor. They took chips of rock and they took it to labs and they aged the rock. And you can do this by what's called radioactive dating. Have you ever heard of radioactive dating before?
Chernobyl.
Can you say radioactive dating?
Radioactive dating.
Nice.
It's the best day.
So radioactive dating works like this. You take a little chunk of rock, and you use a machine to detect the amount of radiation coming out of the rock. And the way it works is this: the older the rock, the less radiation comes out of it, because the radioactive elements decay over time. When they're first formed, they're real radioactive, and then they lose their radioactivity over time.
Like